Okay, so today we're talking about Gibbs free energy, and this is just kind of to get into enzymes because that's where I'm wanting to head with this and get through the enzyme unit. So then when we move on to the DNA unit, we know why we're making the enzymes and how we're making the enzymes. Okay, so Gibbs free energy is marked by this equation: delta G equals delta H minus T delta S. And so H is going to represent enthalpy or total energy. This is like energy in the reaction. We abbreviate reaction RXN at where I go to school. And then S is going to be entropy, and disorder is kind of like a measure of disorder or randomness. So I just think of entropy like my room. Everything wants to move towards disorder. And then T is the temperature. And so really what this tells us is if it's non-spontaneous or not. And so if it's non-spontaneous, then the delta G is going to be greater than 0. And if it is spontaneous, then the delta G is going to be less than 0. Making sure I got that right. Okay. And so this means if delta G is positive, I'm going to put a little plus sign, or if delta G is negative. And so basically, if it's negative, I like to think about this just like the little graphs I've been drawing before. A graph like this, so delta G, the energy went down. So delta G was negative, or less than 0. And so this would be a spontaneous reaction, like a slide. And so this, in biology, this is going to be our cellular respiration. And so we have our glucose, and it's turning into water and our CO2. I know this is repetitive, but really the repetition is good and it makes it Gibbs free energy. Bozeman calls it also available energy, so go check that out. And then the opposite, a non-spontaneous reaction, would be photosynthesis. And so we're taking energy in, energy increase, so delta G is positive, it's greater than 0. It's going to be, this one's endergonic. I covered this yesterday. So this one's endergonic, this one's exergonic. Energy went into the system. So we get that energy from light, from the sun. This one's exergonic. Exergonic. Right, so it should be all kind of clicking now. That in photosynthesis, when we're building, right? So in cellular respiration, we're increasing the entropy because we're coming from one very structured molecule to more little molecules. And so the entropy is going to increase, and then when you increase the S, it's going to make this number more negative. And also, the energy is going to go down in the molecule because we're going to less bonds. Same thing again with photosynthesis, but in reverse. Because we're adding this, we're increasing the order or decreasing the disorder. Delta S is going to go down, and so the subtraction from this is going to go down, which makes it more positive because we're putting energy in. So delta H goes up as well, making delta G positive. And since it's delta G is positive, it becomes a non-spontaneous reaction. So this reaction is non-spontaneous. And so you can think of the spontaneousness like a slide. You don't just go up a slide, but you do just go down a slide. You can push a ball down a slide, but you can't push a ball up a slide. Likewise in cellular respiration and photosynthesis. So you can think about it like a slide. Are we going down the slide from a high energy molecule like glucose to water? If we're going down the slide, then we're losing energy. It's exergonic, or delta G is going to be negative, which is cellular respiration. And if we can't push the ball up the slide, think about, okay, so our delta G is positive. We have to put energy into the system. Delta G is going to go up. It's going to take in energy, endergonic, and that's a non-spontaneous reaction. And so to get a non-spontaneous reaction, one thing from this equation, what we could do is add temperature or energy. And so what we're doing is adding energy from light. And I hope that was helpful.